Before we start, let's have first a review of our previous lesson. Let's play Two Truths and One Lie. So for today's review, I will show you three statements or three sentences. Two of them are true and one of them is false. Statement A. During chemical reaction, new substances are produced. Statement B. During chemical reaction, atoms are destroyed. Statement C. During chemical reaction, the atoms are rearranged. Which is true and which is false? So the lie is statement letter B. It is wrong that during chemical reaction, atoms are destroyed. Remember the law of conservation of mass, wherein it states that the total mass of the reactants is equals to the total mass of the product. So there are no atoms that is being lost or destroyed during the process. Next, two truths and one lie. Identify the lie. After the chemical reaction, the total mass of the reactant should be equal to the total mass of the product. After the chemical reaction, the elements combine to form compound always contains exactly the same proportion of elements by mass. After chemical reaction, the total mass of the reactant are not equal to the total mass of the product. And the lie is statement letter C. It is because after the chemical reaction, the total mass of the reactant is the same as the total mass of the product, because no elements is being lost during the process. All elements that is being combined to form new substance or new compound is always the same to the elements by proportion mass. So for today's discussion, we will discuss the chemical equation. It is a method used to illustrate the chemical reaction using symbols, formulas, and signs. It is the chemist's shorthand for describing the sequence of a mathematical reaction. Remember the following when writing a chemical reaction. First, the chemical formula of elements are used instead of name. Most gaseous elements such as hydrogen, oxygen, nitrogen, and those halogens such as fluorine, chlorine, bromine, and iodine exist on uncombined state as a diatomic molecules, meaning to say, as you encounter a free hydrogen, oxygen, nitrogen, and some halogens, they are always present in two atoms. So for oxygen, there are always two oxygen, two hydrogen, two nitrogen, two chlorine, two bromine, and two iodine if they are free on the situation. Next, this consists of the reactants that is written on the left side of the equation and product written on the right side of the equation. Example is this one. The reactants are hydrogen gas and oxygen, and the product is a water. Next, in between the two reactants, the plus sign is placed of the word "and". So example, there's this one. We have two reactants on this example, the hydrogen gas and the oxygen gas, and these two reactants is added up by a symbol plus sign to indicate that hydrogen gas is added with an oxygen gas to form the product water. Number 4. To separate the reactants and the product, an arrow is placed in between them. The tip of an arrow indicates the direction of the reaction, and this represents the word produced, yield, or form. Example is this one. So as you can see, our reactants, hydrogen gas and oxygen gas added up or react to one another to form water. So arrow indicates that hydrogen gas and oxygen gas combine to form new substance, which is water. Next, there should be the same atoms on the reactant and the product of the same equation. So this time, we will use balancing a chemical equation. Before we proceed in balancing some chemical equation, we need first to identify the parts of chemical formula or chemical equation. So on this one, we have two molecules of water. This one is what we call the chemical formula, consists of the symbol of the element and the number of the atoms present on this molecule. So as you can see, we have two atoms of hydrogen and one atom of oxygen to form a water molecule. And this whole number is the coefficient. It represents how many number of molecule is present. So in this example, we have two molecules of water. Each molecule of water is consists of two hydrogen and one oxygen. Now, here are the steps that you need to consider in balancing a chemical equation. First, take note of the elements present in the reactant and product side. You need to count the number of atoms of each element present in the reactant and product side. Apply the law of conservation of mass to get the same number of atoms of every element on each side of the equation. Balance chemical equation by placing the appropriate coefficient before the symbol or formula. And last, do not change the subscript or the number of atoms of the formula in an attempt to balance the equation, as it will change the identity of the component. Now, let's try it on an example. Get your paper and pen to follow.
So it says that hydrogen gas reacts with oxygen gas to produce liquid water. So our first step is to write the unbalanced equation. So we have a reactants of hydrogen gas, so it would be H2, and an oxygen gas O2. So they order reactants. So it says that hydrogen gas reacts or adds up with oxygen gas to form our product water. So water is H2O. Now to balance this one, count first the number of atoms of each element present in the reactant and product side. So on our reactant side, we have hydrogen and oxygen elements, same as the product. Now, how many hydrogen and oxygen is present on the reactants and the product side? So on the reactant side, we have two hydrogen. This subscript indicates that we have two atoms of hydrogen. We also have two atoms of oxygen. While on the product side, we have two hydrogen and only one oxygen. So as you can see, they have an equal amount of atoms for hydrogen and oxygen on our reactant and product side. So to balance these two, apply the law of conservation of mass, wherein we need to get the same number of atoms of every element on each side of the equation. And to balance the equation, we need to place the appropriate coefficient before the symbol or before the formula. So coefficient is a full number before the chemical symbols. So before is the symbol of element, we need to put a whole number. It's either from 1 up to 9 and so on. So let's take a look. First, let's attempt to add 2 coefficient on the water molecule. It is because we need to have 2 oxygen. So if we will add 2 as a coefficient for the water molecule, we are now having 2 oxygen for the product side. Now, what will happen to the hydrogen atoms on our product side? So as you can see, we will put 2 as a coefficient. It pertains to both hydrogen and oxygen because they are a polyatomic molecule. We need to say they are 1. So if you put 2 or a digit for a coefficient before them, both of them will receive that amount of coefficient. So if you will put 2, parehong si hydrogen and oxygen will have a coefficient of 2, or they will be multiplied into 2. So if you will put that coefficient, you will now have 4 hydrogen for the product side. Now let's go back again to our reactant. So as you can see, if you will add 2 as a coefficient for the water molecule, there is a change on the hydrogen atoms. So we need to change also the reactant sign for us to have balanced equation. So if we will put 2 coefficient on the hydrogen gas, we will now have 4 hydrogen for the reactant and 2 oxygen for the reactant side. So as you can see, we have equal amount of atoms. So we have 4 hydrogen, 2 oxygen. On the product side, we have 4 hydrogen and 2 oxygen. So the balance equation for the reaction between hydrogen gas and oxygen gas to produce liquid water is that 2 hydrogen gas or 2 molecules of hydrogen gas plus 1 molecule of oxygen gas will then produce or form 2 molecules of water. So they are now balanced. Now we have zinc and hydrogen. Now we have zinc and hydrogen chloride reacts to one another to form zinc chloride and hydrogen gas. So first, let's count the number of atoms of each element present on the active side and product side. So first, let's count the number of zinc on the reactant side. So we have 1 hydrogen, and 1 chlorine. On the product side, we have 1 zinc, 2 chlorine, and 2 hydrogen. So as you can see, they are not balanced. It is because we have 2 hydrogen and chlorine on our product side while we have only 1 hydrogen and chlorine on our reactant side. So to balance this equation, let's try putting 2 coefficient on the molecules of hydrogen chloride so that we will have now 2 hydrogen and 2 chlorine. So that's it. They are now balanced. So for us to have this product, we need to have 1 molecule or 1 atom of zinc plus 2 molecules of hydrogen chloride to form zinc chloride and hydrogen gas. For the reactants, we have 1 oxygen multiplied by 3. So if we have 1 sulfur inside the parentheses and we have 3 subscript outside the parentheses, we have 3 sulfur. For oxygen, we have 4 inside and a subscript of 3 outside the parentheses. So 4 times or 4 multiplied by 3, we have now 12. Now to balance this equation, let's try first to balance the oxygen. So we have 12 oxygen on the product and 4 oxygen on the reactant. So let's try having or putting 3 coefficient on this one so that oxygen will now have 12 atoms. So 3 multiplied by 4 oxygen, we have 12 atoms. Now there is a change happens on the sulfur. So we have 1 sulfur here, but we add 3 coefficient on this one, so this molecule is multiplied by 3. So 1 sulfur multiplied by 3, we now have 3 atoms of sulfur. So we now have a balance of sulfur atom and oxygen atoms. While for hydrogen, there is a change happens on the hydrogen here because we added 3 as a coefficient. So now we have 6. While on the product, so let's try putting or writing 3 coefficients so that on the product, last for the aluminum, let's have 2 as a coefficient here so that we have 2. So as you can see, we are now have a balance equation wherein 2 aluminum atoms or 2 aluminum plus 3 hydrogen sulfide will produce aluminum sulfide plus 3 molecules.
Balancing equation is the trial and error. There is no exact rule to balance chemical equation. It is just like a life while riding a bicycle. To keep your balance, you must keep moving. You need to try until you find the exact or the correct chemical equation or a balanced chemical equation for a certain chemical reaction. So that's it. Thank you for watching. You can now proceed to your task activity.